All right, so you already know that secant reciprocal cosine, cosecant reciprocal sine, cotangent reciprocal tan. You could also say, by the way, that cotangent, or I have it right here, that cotangent is cosine over sine, and tangent is sine over cosine. So what you're going to be doing, guys, is you're just going to transform, and it's going to be very basic. So check it out. So look at example 1. It says transform sine x cotangent x into cosine x. So all you're going to be doing is this. So you're going to go sine x. And then cotangent x is the same thing as cosine over sine x. So times cosine x over sine x. And what's going to cancel? Yeah, the sines. The sine x cancels out and you just have cosine x. So then you can just make a statement and you can say, so sine x cotangent x is nothing more than just cosine x. So you guys see that, guys? And it is how you show the work. Sometimes they put a little triangle. It stands for therefore. And then therefore, sine x cotangent x equals cosine x. All right. And you don't have to put the arrow. You can just put the equal sign. Hey, Alvarez. What's up? Okay. So don't worry. You just missed one question, but it's very basic. So yeah. So if I were to tell you something like, what is tan x times cotangent x? Well, tan x is sine over cosine. And cotangent x is cosine over sine. So notice how everything just cancels out. So you just have 1. And that's it. All right, I'm about to tell you guys something so awesome because Valentine's Day is coming up. And so yeah. So look, it says, let's chat about the unit circle again. And don't worry, we're going to just briefly chat about it real quick. The equation of the unit circle in Cartesian format is x squared plus y squared equals 1. Cool? Now remember, when you guys were doing the unit circle, where we said this was 1, and when we said SOHCAHTOA, and I guess I should have put a dash there instead of a comma. So we said we called this distance the x distance. We called this distance a y distance. So we had a coordinate there, x comma y. So then we said sine theta, if this is theta right there, was equal to y over 1, so y. And then cosine theta was equal to x over 1, so x. We haven't done anything crazy, right? Look what we can do. We can replace this x with cosine theta. Cosine theta squared plus we can replace that y with sine theta. Sine theta squared equals 1. And there's a real easy way to remember this. Here's the easiest way that you can remember it. And I actually do want you to write it as a Valentine's card. So when you write a Valentine's to your babe, you're going to say that you are cosine squared and your babe is sine squared, and together you guys are 1. You don't think that's cool? And if they don't get it, dump them and upgrade yourself because you deserve better. No, for real. I mean, if they don't get it, upgrade. Like, oh, I don't get it. Like, well, try to educate them first. Like, oh, because it's a property, cosine squared plus sine squared equals 1. And if they're still like, huh, just drop them and get another one. All right. Now, if they don't know cosine squared plus sine squared equals 1, yeah, drop them. Okay, so by the way, guys, that squared, this is how you would see it sometimes in textbooks. The square is immediately after the s, not the theta. Do not confuse this with this, because it is not. In this one, the argument is being squared. Chavez, what's argument? Like the parentheses. That is not the same. This cosine theta squared means that it's a cosine that is being squared. Are we in the clear, guys? Okay. This is your first Pythagorean identity. Cosine squared plus sine squared equals 1. You could also do some stuff to it. So let me rewrite it again. Cosine squared plus sine squared equals 1. And what if I decide to divide everything by cosine squared? divide by cosine squared, divide by cosine squared, divide by cosine squared. So then you get 1 plus tan squared, because sine over cosine is tan, right? Equals, what's 1 over cosine? Everyone at the same time. Secant squared, guys. So this is your second rule. So circle that one and circle this one. We got one more. So I'm going to rewrite it. I'm going to write cosine squared again plus sine squared again. I'm going to equal it to 1. And what if I divide everything by sine squared? Divide by sine squared, divide by sine squared, divide by sine squared. Here's how we're deriving them. I hope you don't want me to just say them, right? Like you want to derive them. Cosine divided by sine, that's the same thing as cotangent. Put a square on it because there's squares on both. Plus sine squared over sine squared, that is a 1, equals 1 divided by sine squared, that is the same thing as cosecant squared. And this is the third property. They're all Pythagorean properties. Use them where they help you out. Does that make sense, guys? Okay, so here we go. Let's go to turn the page. And it says transform cosine squared minus sine squared into 1 minus 2 sine squared. So here's how we're going to do it. You're going to write cosine squared x minus sine squared x equals, and then I want it to equal that. So on the side goes side note, and the only property you know right now is cosine squared x plus sine squared x equals 1. That's the only property you know, but Valentines Formula, that's what we call it. It doesn't matter which one you choose. Well, it does matter. It doesn't matter which one you choose. Notice that the answer that I want only has sine squared. Do you guys notice that? So that means solve for cosine squared because we're going to substitute. So I'm going to write cosine squared x equals, I'm just going to move that to the other side, 1 minus sine squared x. This is what I'm going to sub, guys. Right spanking there. Spanking. Why did I use that word? Such a dumb word to use. Okay, so here we go. So substitute, guys. 1 minus sine squared x, close it, minus sine squared x. You don't have to use the parentheses. I just did, but there's nothing in the front of them, so you can just drop it like it's hot. 1 minus sine, I know, that was dumb. 1 minus sine squared x minus sine squared x. How many sine squares do you see? So 1 minus 2 sine squared x. And there it is. Did we prove it? We did. So you can go little triangle, which means like therefore, cosine squared x minus sine squared x is nothing more than 1 minus 2 sine squared x. I actually like the equal sign better than the arrows, than the implies. How do we feel, guys? Yeah. Look, we already finished 2 examples. Right out. Now we're going to the third. Prove algebraically that 1 plus cosine times 1 minus cosine equals sine squared x. All right. You got to know how to FOIL, guys. You got to know how to distribute. You either take this one and multiply by everything on that side, or you do the FOIL first out in last. It doesn't matter. They're all just tricks. So what you do is you take this one and you multiply by everything on that group. What's 1 times 1? 1. What's 1 times negative cosine x? Negative cosine x. Once you've exhausted that 1 times everything on the second group, you're done. You go to the next one. Cosine x times 1 plus cosine x. Cosine x times negative cosine x minus cosine squared x. And hey, don't worry, don't yawn. The cosine x's cancel out, and you get something like this. And I know what you're thinking. You're thinking, Chav, I have no idea how you're going to prove that to be sine squared. So you go back to the only formula you know. You just know the Valentines formula. Cosine squared x plus sine squared x equals 1. Yeah? And look, I want you to recognize, so look what happens when I move this cosine squared to the right. You get sine squared x equals 1 minus cosine squared x. OMG, isn't this 1 minus cosine squared x? Yeah, what's 1 minus cosine squared x equal to? Sine squared. So then you can put a little triangle with 3 dots, and you can say 1 plus cosine x times 1 minus cosine x does in fact equal sine squared x. Yay or nay? Yeah. All right, guys. You guys are killing it. Let's go to the next one. It says, uh-oh. Prove algebraically that cotan A plus tan A equals cosecant A secant A. So A is the argument. If you want to put parentheses, you can. A lot of times, you guys don't put that A. You got to put that A, guys. Cotangent can't be by itself. Okay, so here's what I see. I'm going to break down cotangent and tangent into sine and cosine. So I'm going to write it. Cotangent A plus tan A. And I know that cotangent is cosine over sine. So I'm going to write cosine A over sine A plus, I know that tan A is sine over cosine. I want to add them. You can't add them unless you have a common what? Denominator. So I'm going to multiply this fool, or this dude, by cosine A over cosine A. And I'll multiply this guy by sine A over sine A. When I do that, here's what I'm going to get. I'm going to get cosine times cosine, which is cosine squared A, over, and I'm going to write it as sine A cosine A, plus sine A times sine A, which is sine squared A, over, and I'm going to put the sine A first, just to be consistent. Are my denominators the same now? Hell yeah, they are. I wish I had pyrotechnics. They're the same. So I'm going to add them both together because I know it's hard, guys, to come back from a 3-day weekend. You guys probably, your sleeping schedules are all messed up because you got used to waking up like at 9 or 10. So this is considered early for you guys. So I know some of you guys are still asleep. But if we had pyrotechnics, we could put like a whole bunch of flames and it's like a little concert and maybe that'll wake you up a little bit. So there it is. I have that. And then you're probably saying, Chab, that doesn't look like my answer. They have cosecant, secant A. I don't know where to go from here. I want you to recognize there should be some red flags. I see the Valentines formula in there. Do you guys see it? What is cosine squared plus sine squared? That's 1. So you're going to come back and you're going to be like 1 over sine A cosine A. And then you're like, Chab, I don't know where to go from here. We're done. You can break this up, guys. You can do this. Look, you can go 1 over sine A times 1 over cosine A. Can I not? Yeah, that's the same. They're the same. What's 1 over sine A equivalent to? Cosecant A. What's 1 over cosine A equivalent to? Secant A. OMG. OMG, it's the same. That's what that is up here. So then there it is, you proved it. You put 3 little dots in a shape of a triangle, and you just go, that means cotangent A plus tan A is equivalent to cosecant A secant A. How do we feel? I woke up and I did some math. Math, not like, okay. All right, I'll stop. That I would like what? I don't know if I've heard of that song. Is that the one that goes la 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 la? Yeah. Oh yeah, I like that song. I just don't know the lyrics, so I can't sing it. I just can hum it. Are the lyrics bad or are the lyrics good?
No, it's actually a good song.
Okay.
It's like very uplifting,
Okay. Okay, I'm gonna listen to it tonight. All right, so here we go, guys. Is this the last one? Yeah, there's the last one. Look, so that's it. We just have this one little activity that you should be able to finish really quick, and you're done. So it was easy Tuesday. Prove algebraically that 1 minus cosine B over sine B equals sine B over 1 plus cosine B is an identity. Okay, so you can actually take the right side to equal the left side, but I'm going to take the left side to equal the right side. So I'm going to do this. I'm going to write 1 minus cosine B over sine B. And so here's where your experience comes in. You're like, I don't know what to do here. So hopefully something inside of you is telling you, maybe we should multiply by the conjugate of the numerator. Do you remember the word conjugate? Oh man. Okay. Side note. Remember when you had something like what's 1 plus 3i in algebra 2, and they told you what's the conjugate of 1 plus 3i, and you said 1 minus 3i? So that's what the conjugate means. You're just going to switch this sign and turn it into a plus. So I'm going to multiply this by the conjugate. So I'm going to go 1 plus cosine b over 1 plus cosine b. Now, what I'm really doing is multiplying by 1, so nothing is changing. When you multiply by the conjugate in the numerator, you're just going to get the difference of squares. So this is going to turn out to be 1 minus cosine squared b. And I know what you're saying, like, Chav, how did you just do that so fast? Well, no, I'll tell you in a little bit. In the bottom, I'm not going to distribute. I'm going to leave this like this. Okay, side note. Why is multiplying by the conjugate so awesome? Because 1 minus cosine b, you can just multiply the outers. What do you mean, Chav? 1 times 1 is 1. Cosine times cosine is cosine squared. Put a minus, and that will always be that. Why? Well, look, 1 times 1 is 1. 1 times cosine b, so plus cosine b. And then negative cosine b times 1, that's negative cosine b. And then negative cosine b times the positive cosine b, negative cosine squared b. Look at the middle. One's positive, one's negative. They zero each other out. And you just get 1 minus cosine squared. This is why multiplying by the conjugate sometimes is so useful, because you get something like that. And then side note again, one more side note. You're like, okay, what do I do now? Notice that's 1 minus cosine squared. From your Valentines formula, cosine squared b plus, I can change the argument to whatever I want it to be, plus sine squared b, as long as it's the same, right, equals 1. I can make that look like 1 minus cosine squared by just moving that to the other side. So sine squared b is equal to 1 minus cosine squared b. Do you guys see that? So now that I've done that, 1 minus cosine squared b is nothing more than what? Sine squared, yeah. So it's going to go sine squared b in the numerator over sine b parenthesis 1 plus cosine b. Now, and I'll wait for you guys to catch up. I want to take a sip here of the juice. The juice. Now, because I have sine squared on the top and sine b times 1 plus cosine b, I have a quotient or something that's being divided. Remember, this means sine squared times sine squared. That means sine b times sine b. So how many of these can I cancel out? One of those. Bam, out, bam. So here's what you have. Sine b over 1 plus cosine b. Is that what I had on the right-hand side? Yeah. So then you can put a little 3 dots in triangle form. Therefore, 1 minus cos b over sine b is equal to sine b over 1 plus cos b. Done. How do you guys feel? All right, we have one little paper. It shouldn't take you more than, I don't think, 10